In this tutorial, we will be learning on what happens for SR Latch when we are using with the NAND gate when enable switch is been applied over there. Here, it means like suppose if you are having any switch that is to be enable, you can have two options. Either you can make the switch it off or you can make it on. Here off means the value at enable you are making it as 0 and for on it is 1. And for the NAND gate, the truth table is been shown over here. This is the output for AND gate, and for the NAND gate the output would be 1 1 1 0. That means if any one of the input is 0, my output is high, and if any one of the input is 1, we cannot comment on the output that we have done in our previous tutorial. So as you can see in the figure, I have two inputs. Say this is S, this is R, and enable switch. And enable has been sorted to both of the inputs of that corresponding NAND gate, and the output, say the generated output from S and enable be S star, and the generated output from R and EN should be R star. So now let us start first the case for S star and R star. So for what will be S star? S star is nothing but S dot EN, S dot EN whole bar. So what you will do is, first case, let enable should be equals to 0. Case 1, what if enable equals to 0? If enable equals to 0 implies 0 dot S would be 0, 0 bar would be 1. So S star would be 1. Similarly, if you say about R star is nothing but R dot enable bar. As enable is 0, it would be here R dot En bar, so it will be 0 bar, again it would be 1. Now, as we know, if the input for the NAND gate is 1, we cannot comment on the output. That means when enable equals to 0, if we cannot comment on the output, the state will be of memory. So we can write it as when enable equals to 0 implies the output is nothing but memory. That means whatever the previous value was there, that will be retained. Now what is enable equals to 1? As enable is made as 1, now we need to divide into 4 cases. That would be when enable equals to 1 implies S star equals to S dot En whole bar. What is S? S is S. We will be taking over the cases. Enable is 1, so the result is S bar. Similarly, R star is nothing but R dot enable bar, and that will be equals to R dot 1 whole bar. That will be equals to R bar. Now let us analyze the cases when S equals to 0, R equals to 0. For S is equals to 0, R is equals to 0 implies S star is equals to S bar, that is equals to 1. R star is equals to R bar, that is equals to 1. S star is equals to 1 and R star is equals to 1. The same concept would be equals to memory. The first case when S is equals to 0, R is equals to 0 implies the cases of memory. Moving on to the next case where S is equals to 0 and R is equals to 1. Say this is case 1 for all the cases we are discussing when enable is high. Similarly for case 2, S star will be equals to 1, R star will be equals to 0. Now as you can see, if one of the inputs, say R star is equals to 0, if any one of the input for NAND gate is 0, my output is always equal to 1. So Q of T bar equals to 1. If Q of T bar equals to 1, my case would be this 1 will be sorted over here, 1, and 0, output would be 0. So when S star is 1, R star is 0 implies Q of T equals to 0 and Q of T bar equals to 1. So this is the second case. Similarly, talking about case 3 would be when S is equals to 1 and R is equals to 0 implies S star will be equals to 1 bar, that is 0, and R star will be equals to 0 bar, that will be equals to 1. So let me apply the cases for which S star is equals to 0 and R star is equals to 1. This would be 0, this would be 1. Again, if any one of the input is 0, if any one of the input is 0, my output will be high, so this will be 1. This will be sorted, so this will be also 1, 1, and 1, output will be equals to 0. Implies when S is equals to 1, R is equals to 0, Q of T equals to 1 and Q of T bar is equals to 0. And the final case would be case 4 when S is equals to 1 and R is equals to 1. S is equals to 1 implies S star will be equals to 0 and R equals to 1 implies R star will be equals to 1 bar, that is nothing but equals to 0. If both the inputs are 0, irrespective of whatever the next input will be, my output will be always equals to 1. So this is also 1, this will be also equals to 1. That means q of t is equals to q of t bar is equals to 1. This is complete not a valid scenario because it is complement, so it should be opposite to each other. So this s is equals to 1, r is equals to 1 is a not valid case. So as you can see, the only impact which we have got is after applying the switch, if you have make it as 0, it will be considered to be memory. That means whatever previous value has been stored, it will be following that. And for enable equals to 1, we have done the 4 cases. Say this is S, this is R, this is S star, this is R star, and I will be writing Q of T. So first case 0 0 0 1 1 0 1 1. These are all when enable is high. As we know, enable if it is low, irrespective of S and R, my output is always 1. So the case would be of memory. Now for 0 0, it is case is 1 1. For 0 1, it is 1 0. For 1 0 0 1, and for 1 1 0 0. As S star and R star, as we can see the output, so this is nothing but memory. This is 0 and 1 1 0 implies S is equals to 0, R is equals to 1. My output is Q of T as 0. For the third case, when S is equals to 1, R is equals to 0, my output Q of T is 1. And for the fourth case, when S is equals to 1 and R is equals to 1, I got the case as not valid. So this will be not used case. So this is all about SR latch using NAND gate. Hope this tutorial is clear to you all.